1.4 Complex Numbers Preparation. Factor out the greatest common factor. Okay, so previously we learned how to factor out or find the greatest common factor, and what we're going to do is factor it out. And basically what it means is first we find the GCF, and that's the most important part of this, find the GCF of these two terms. So the GCF, or the greatest common factor, one would think of that as the largest thing you can divide evenly into a 5, and a 10 is a 5. And the other part is to look at the elements, even the variables, and find the lowest common, the lowest exponent. So we have a 2 there and a 1 there, so 1 is smaller, so we know that the GCF must be a 5y. When we factor it out, essentially what we're doing is we are dividing the terms by the GCF, right? And whatever is left over, we put inside of a set of parentheses. So 5y squared, the 5's cancel out, y squared divided by y to the first power. We do something called the quotient rule of exponents, which means we subtract, and this should make sense. So x squared divided by x to the first power is the same as, y squared divided by y to the first power is the same as saying y times y over y. And notice that these two would cancel out, leaving you 1, which means you'd end up with y to the first power. So the rule that we use is we say 2 minus 1 equals 1. And that should make sense. Again, if you have two y's on the top and one y on the bottom, one y on the bottom will cancel out with one y on the top, leaving you one y on the top. So all the leftovers go where you had the larger exponent. So if I had more y's on the bottom, I would have left the y's on the bottom. And we'll go over this rule more later, but right now we're just going to do some simple ones. Okay, so what this does is it leaves us a y. Over here we say 10 divided by 5, which leaves us a 2. And it's a positive 10 divided by a positive 5, which leaves us a positive 2. And now we say y to the first divided by y to the first, and those just simply cancel out. So you end up with 5y multiplied by y plus 2. All right, so let's try another one. So what we have here is we have x to the 5th power plus x to the 3rd power. It looks like the GCF of this is simply going to be x to the 3rd power. Each element to the lowest power, because we're doing the GCF. And the lower of 5 and 3 is a 3. So we divide both of these by x to the 3rd. Put x to the 3rd outside the parentheses. And whatever's left over after division, we put within the parentheses. So x to the 5th divided by x to the 3rd. 5 minus 3 is 2. X to the 3rd divided by x to the 3rd. The whole thing goes to 1 because anything divided by itself is 1. So we just put a 1 there. And then we're done. All right, let's try this one. So now we're going to say 20, 10, and 15. It looks like the GCF so far is going to have a 5. You can go back and review the rules for division, but we know that since this ends in a 0, and a 5, the GCF is going to be a 5. Okay, then we have m to the 5th, m to the 4th, m to the 3rd. So we know it's 5m to the 3rd. We pick the smallest exponents. Okay, cool. So we divide all of these by 5m to the 3rd, 5m to the 3rd, and 5m to the 3rd. Now, be careful. In the future, I'm not going to write the division of every one of these. Eventually, just do it mentally. And if you look online or you look on Help Me Solve It on My Math Lab, it's probably not going to show you this step. That's okay. But this is actually what you're going to be doing. So we are going to say 20 divided by 5 is 4. M to the 5th divided by m to the 3rd is m to the 2nd. And this is actually supposed to be in front. Make it more obvious. There we go. No, separate these two. Okay, so 5m to the 3rd is the part in front, and then all the rest goes inside. Keep track of your signs. Positive 10 divided by positive 5 is a positive 2. M to the 4th divided by m to the 3rd is m to the first power, or just m. Minus negative 15 divided by positive 5 is a negative 3. And the m to the 3rd just cancel out. And there we go. Let's try the next one. We have a 20 and we have a 36. It looks like we can divide both of those by 4. And we have m to the 7th, m to the 3rd, so we include m to the 3rd. We have p to the 2nd, p to the 4th, so we know we have a p to the 2nd. And then we leave everything else in here after dividing. So let's see if we can divide. 20 divided by 4 is 5. M to the 7th divided by m to the 3rd is m to the 4th. P to the 2nd, p to the 2nd, those just cancel out. Negative 36 divided by positive 4 is a negative 9. M to the 3rd divided by m to the 3rd, cancel out. P to the 4th divided by p to the 2nd leaves me 2. 4 minus 2 is 2. and then we're done. So normally you don't write the GCF off to the side, you don't write all the division, you just kind of do most of it mentally. But if you need to write it out, by all means, write it out. Write it out as long as you need to. Okay, so let's try this one. So we have an 8, a 16, and a 4. It looks like the GCF is going to include a 4. We have x to the 4th, x to the 3rd, x to the 2nd. So we include x to the 2nd. So what we're going to do is we're going to have 4x squared, parenthesis, parenthesis, and we divide -8. Now, normally if the leading coefficient is a negative, you factor out a negative. I'll explain why later, but it's just a good habit to get into. So since the leading coefficient is a negative, I'm going to factor out a negative. Now what that's going to do is, since now I'm effectively dividing all these by a negative, right? By a negative 4x squared, by a negative 4x squared, that I'm going to have to flip all of the signs. So a negative 8 divided by a negative 4 is a positive 2. X to the 4th divided by x to the 2nd is x to the 2nd, because 4 minus 2 is 2. A positive 16 divided by a negative 4 is a negative 4. X to the 3rd divided by x to the 2nd is just an x. Negative 4 divided by negative 4, anyways, anything divided by itself is just a 1, so this just turns into a positive 1. We move on to the next one. Now this looks a little bit different in that we have these parentheses here. But the largest thing, the greatest common factor of both of these is literally going to be the parentheses. So the GCF, in this case, is going to be a plus 3. Okay, so we simply divide both of these by a plus 3, a plus 3. And again, you don't normally write this out. Those are going to cancel out. So we rewrite the a plus 3 in the front. Within the parentheses, we put the leftovers. So that a right there is going to be part of it. And this 4 right here is going to be part of it too. So we put the a plus 4 within the parentheses, right? Whatever's left over after division. Or you could look at it a different way, that you just basically pulled this parenthesis to the front. Now, order doesn't matter in this case, so you could have just as easily said a plus 4 multiplied by a plus 3. Let me make that 3 look a little better. There we go. Ooh, that looks terrible. Okay. Let's try the next one. The next one, again, this is what I meant by just pulling it forward. So you don't have to write all these steps, right? So I can just put x plus 1 there, and x squared minus 5 goes on the second one, right? Factoring by grouping is, we do what we just did, but we basically just do it twice. You do factoring by grouping when you have 4 terms. So we have 2 terms there, and another 2 terms there. So factoring by grouping, the first step is you just group. You get a couple of groups here, right? So you have 4 terms. That's an indication that you're probably going to do factoring by grouping, and then you just group it into 2 groups, and then you factor just like you did before. What's the GCF of a 2 and a 6? Well, that's a 2. What does that leave me? 2x divided by 2 is x. 6 divided by 2 is 3. What about ax plus 3a? Well, what can I divide both of those by? Well, an a. And what does that leave? Well, that's an x plus 3. Notice that x plus 3 matches. Now we pull it to the front. X plus 3 multiplied by 2 plus a. Let's move over here. We have 6ax plus 24x. The largest thing we can factor out of that looks like we could factor a 6 out. We also have an x, so we factor the x out. And 6ax divided by x is a. 24 divided by 6 is 4. X divided by x just cancels out. So we end up with a plus 4. Plus, we can factor a 1 out of a plus 4. There's just an implied or understood 1 there. So I'm actually going to explicitly write it out. It makes it a little easier later. So now we have the parentheses a plus 4 multiplied by 6x plus 1. Try it over here. We have a 2x squared minus 10x. We can factor a 2 out of both a 2 and a 10. We can factor an x to the first power out of an x squared and an x. And that leaves me x, right? 2x squared divided by 2x. Now, if you have to write the division step, write the division step, right? I'm just doing it mentally, but if you still need to write it out, by all means, write it out and do it step by step. That's not a bad idea to begin with, right? The negative 10 divided by positive 2 is a negative 5, and then x divided by x just cancels out. Plus, we have 3xy minus 15y. We can factor a 3 out of a 3 and a 15. We have an xy and a y. We can factor a y out of both of those. And that leaves me the x minus 5, right? Because negative 15y divided by positive 3y is a negative 5. So that leaves me the x minus 5 multiplied by the 2x plus 3y. Let's try this one. So I can factor the I can factor, what can I factor of a t to the third power and a t to the second power? I can factor a t to the second power, right? T cubed divided by t squared, 3 minus 2 is 1. Then 2t squared divided by t squared, the t squares cancel out, leaving me the 2. Now, here's a little bit different. Now, since this has a negative leading coefficient, I'm going to factor out the negative. What can I factor out of a 3 and a 6 is a 3. But because I'm factoring a negative out, I have to flip the signs. Okay? So negative 3t divided by negative 3 is a positive t. Negative 6 divided by negative 3 is a positive 2. Okay? And the reason that is important is because when I redistribute this, I need to have that negative to get back the original. And I'll give you an example of checking that later on. That's it.